All right, I'm here with Andrew Huberman, professor of neurobiology at Stanford. During the biohacking expert interview series, I was fortunate enough to sit down with 40 of the luminaries in the biohacking space, and there were a couple interviews that really stood out, one of which was my conversation with Andrew Huberman. And Andrew's a world-class expert in neuroplasticity, ways to biohack the brain, and we thought it would be really fun to get together and go into a course where we teach you step-by-step some of the most advanced strategies for upgrading mental clarity, focus, and brain power. So I'm really excited. Andrew, thanks for flying out. Let's start out with, how'd you get into all of this?
All right, well, first off, great to be here. It's a real honor and privilege. So I've been involved in neuroscience in one form or another for over 20 years. So I'm a career academic. So I started off studying what we knew about the brain 20 years ago in an undergraduate lecture course. Just immediately grabbed me in terms of my interest in understanding how the brain works, why people differ in their behaviors and their activities. Some of this also reflected, some life experience of seeing, people get depressed or people become, unfortunately, mentally ill. Some people recover from that, some people don't. And it just really sparked a deep curiosity. Although, to come clean, I have to say, my dad likes to tell a story. My dad's a scientist also. I was 6 years old and asked him what he did, and he's a physicist, so he said he studies the universe. And I said, well, that's interesting. I want to do that. And he said, no, you don't want to do that. There's a lot already being figured out fast. And I said, well, what don't we know? And he said, well, we don't understand how the brain works. And I said, well, that's what I'm going to do. So that's what lit the fire, and I've been doing it ever since. I, did my undergraduate degrees and professional and academic degrees in neuroscience. And along the way, I now run a big laboratory that studies neuroplasticity and brain repair and other topics, including things like fear and cognition. But one of the things that I've always enjoyed doing is being a real student of the field. So I have all these wonderful colleagues who do tremendous work in all the different areas of neuroscience. Many are trying to cure Parkinson's and autism, Alzheimer's. These are fundamentally important problems. Many of them are just trying to figure out how the brain works normally under healthy states, how we learn, how a child learns language, all these incredible things that make us uniquely human. And so I've really enjoyed being a student of the field, learning as much as I can through reading and talking to these magnificent colleagues. And really, my great excitement nowadays is translating that for the general public in ways that they can understand, and hopefully inspiring a few budding young neuroscientists as well.
Yeah, as someone with a father who has Parkinson's, this is a topic that's very dear to me. And one of the things that I really like about you is how you're able to take these complex topics and explain them in a way that's so easy to understand. We were talking offline about the difference between how the brain works and how to work the brain. Can you explain that in a little bit more detail?
Yeah, that's a phrase I just love, because I think that, it's one thing to really understand all the working parts of something. I mean, this is one of the goals of modern neuroscience, figure out the complete parts list. They call it the connectome. If you knew it, it's sort of borrowed from the notion of genome. If you know all the genes and how they work, then maybe you understand something important. And I think it's true that one would understand something important about how genes function and how they impact our lives, for the better or for the worse. So likewise, if you understood all the connections, the connectomics, then you might be able to understand how the system works. I think that's likely to be true in parts. It's one of these things that we say is necessary to understand all the parts, but it's not really sufficient to explain how the brain works. And at the same time, let's just say we did understand how the brain works. Let's say we had a brain in front of us and we could say, yeah, that part does this and that part does that. And that's a wonderful goal and a lofty goal. And it's one that myself and many other scientists are pursuing and will be doing for decades, maybe even centuries. But, at a basic level, all of us are going to be alive for roughly 100 years or so, at least with existing biological skill and technology. About a 100-year lifespan is pretty good. And at the same time, we all want to enhance our lives. So if we can appreciate that the brain is an organ, much like the lungs or the heart are organs, and we can understand what the main job or what the main function of the brain is to do as an organ, then we actually stand a fighting chance to do things to change the brain. So when we say how to work the brain, the way I think about that is, what can I do on a daily basis, on a weekly basis, on a yearly basis, or on a lifespan basis to ensure that I'm feeling as good as I possibly can feel, that I'm as connected to the people that I care about and love as I would like to be, that I'm enhancing my, what we call our life experience, that I someday will pass away, having had many, many incredible experiences under conditions where I feel very good, and to constantly be upgrading the software and hardware of our brain, if you will, to kind of steal phrases that other people have used, is so that day-to-day existence is better and better all the time. I think we take for granted the idea that our brain is an organ, and we sort of assume that we are slaves to whatever our brain happens to be doing, but that's not true. Your brain is an incredibly adaptive organ. So when we say work the brain, how do I work my brain? It's the same thing. How can you make your car perform as well as it can? Well, regular maintenance, putting the right things in it, and driving in a certain way, and as opposed to driving in other ways. There are great ways to destroy your car if you drive it improperly. There are great ways to enhance the life of a car, maybe even make it better. If you're thinking about a brain, there are ways to actually perform your brain, to run your brain that can actually make it better than it was before. And that, in fact, is the essence of the brain, to get better and better over time.
What are some myths and common misconceptions about the brain?
Okay, so I think one of the most, there are some kind of pop culture myths about the brain. One of my favorite ones that often comes up is that, that at any given time we're only using 10% of our brain, or sometimes people change that percentage and they say 1%, but it's always a very small percentage of the total of possible percentage, which would be 100. And to that, I sort of always chuckle, which is this is probably a good thing that you're only using about 10% of your brain at the time, because if your whole brain were active at the same time, you'd have an epileptic seizure. So the idea that you're only using 10% of your brain and that's somehow limiting is I consider a myth. That's a feature of your brain's specific role in performing. I don't think you want all your muscles to contract at the same time either, but that you wouldn't look at a high performance runner and say, well, that guy's pretty good, but he's really only contracting about 30% of his muscles at any given moment. Put that guy into a state of tonic contraction everywhere and try and make him run. So that's a funny one that comes up again and again. I think that lost in that sort of myth about 10% of the brain or 1% of the brain is something fundamental and important and really exciting about the brain, which is that the brain has these specialized networks, what we call circuits, these series of connections between different areas that when they're active, yes, it might just be 10% of the brain, but that's a good thing because those circuits are designed to perform very specific roles as simple as reaching out to pick up a pen to write on a piece of paper, or roles that you're not even conscious of, like the ability you're walking along and the ability to think back and say, I remember my grandmother, I remember her hands, I remember how they felt, I even remember the smell of her kitchen. Those are specific neural circuits that are activated during those thoughts or those behaviors. So I've used that 10% myth as a way to segue into something about how the brain works. But the next time someone says, when we only use 10% of our brains, you can say, well, that's a good thing. Yeah. Another myth about the brain,
Roughly what percentage do we use?
Well, I think across a given day, you probably use the whole thing. Right? Your hypothalamus is constantly regulating your temperature. It's regulating other sort of basic, what we call autonomic functions, things that you aren't aware of, your breathing, your sleep rhythms, your wakefulness, how alert you are. And then at some point during the day, you're going to look around. And if you're a sighted person, so unless you're blinded, you are going to look out and use your visual cortex. You're going to use your retina. You're going to use all the parts of your brain that are responsible for vision. I should even say, this is kind of an interesting point perhaps to make at this moment, which is that even in blind patients, nothing goes unused. So blind patients use their visual cortex for braille reading. The brain is so adaptive and so efficient that in people that have been blind since birth, or even blinded later in life, an unfortunate event, the brain says, this real estate is open, and now I have the requirement that most people don't have, which is to use the tips of my fingers in order to evaluate very small differences in the indentations and bumps on a page, what we call braille reading. And they use their visual cortex, the area that normally would be used for vision, for that tactile function. So the brain, that illustrates really nicely how the brain, and especially the neocortex, the outside part of the brain, is the most highly evolved part of the brain that's constantly updating what it does according to what you need. So for a blind person, that's braille reading. For a sighted person, that's seeing. So going back to your question, I think across the day, you can be pretty sure that when you go down to sleep at night, you've used about 95% of your brain. And then while you sleep, you're going to use the other 5%.
What you're saying is really interesting. So when we were talking about myths earlier, one of the ones that I hear a lot is that we have these different compartments of our brain and they all have these different specific functions. It sounds like what you're saying is there's a lot of overlap. Mm-hmm. It's not, would you consider that to be a common misconception?
Mm-hmm. Yes, in the sense that ultimately everything's connected to everything. If I were to trace the connections between one neuron and one neuron, the connectome that I mentioned earlier, got the complete connectome, what you'd find is that everything is connected at some level. Yeah. Just as I'm sure that there are someone, I've never been to Malaysia, it'd be wonderful to visit someday, but I'm sure there's someone in Malaysia who might be watching this right now that I don't know that I'm connected to, but ultimately I am connected to through the course of human evolution and family lineages, right? Just like every neuron is connected. Now, at the same time, there's specialization of function. So we know, for instance, that the eyes are important for seeing it, that the ears are important for hearing. Those two sensory modalities, as we call them, eventually converge. You have connections, brain connections that are responsible for hearing, and they're responsible for seeing that converge at some location. Even though we normally think of those as separate channels, they converge. And a good example of this is if I snap my fingers over here, generally the response to that would be to look over in that direction. Now, the reason you look in that direction and as opposed to in the opposite direction is because there's a nicely coordinated circuit that links where things appear in your environment and what you hear in your environment. If you hear a bus coming from your right, you tend to look towards your right. There's a reason that you do that. It's also linked to the motor circuitry that forces you to look to your right. So ultimately, everything's connected to everything. But those examples that I just gave illustrate that everything's connected to everything in a very deliberate way. The thing to really appreciate about the brain, whether you're a neuroscientist or you care nothing about neuroscience, is that this organ is exquisitely built. This is the most complex object in the universe in terms of the number of parts and the way they're connected, and it handles everything that we know as our experience. Everything from our memories of things that happened to us earlier to the things that we can anticipate happening tomorrow based on what's happening now, our ability to imagine things, see things, hear things, move, learn new things. This is a miraculous organ. And even though I've spent 20 years, or you could think about the 6-year-old kid thinking about the brain back then, basically my lifetime studying and researching the brain, not a day goes by where I'm not just amazed in some way and just fascinated by how incredible this organ is and its ability to learn and acquire new information and just make our lives what they are. It in fact makes us who we are. You are whatever your brain thinks you are. So we could talk about that. That's getting a little abstract, but this is a remarkable organ and it's our job, and I feel our duty as human beings to really understand it. And once we understand it, to take advantage of its unique ability to change in order to enhance our lives and the well-being of everybody's life, enhance the planet.
This may be a difficult question to answer after that last response, but how would you explain the brain's specific job?
Okay, so I'd love to say that it has a specific job. I'm gonna kind of wriggle around your question a little bit and say that it has 3 specific roles, okay? If I had to pick one answer, and you really just, you really forced a single answer, I'd say that it is the control center for the body and the nervous system. But that's kind of a cheat as an answer, because really that's just kind of circular. I'm just saying, well, it's in charge, and so it's in charge of everything. The brain is responsible for all our perceptions, thoughts, and behaviors. That's its job. It is the control center for generating all our perceptions, which are the things that we look out. I see your shirt is black. I see your shoes are brown. That's a perception. Our thoughts, I can think, okay, I'm here today, I'm sitting in this chair, I'm talking to you, that's a thought. I just think it, great. That's brain generated. And our behaviors, my ability to reach out and interact with the world, move my head and so forth, walk. So that's its singular job. At the same time, it has multiple roles that are a little more mysterious and cryptic, but that we all can understand once we begin to talk about it a little bit. The first one is that your brain is a map. Your brain is a map of everything around you in terms of what you could touch and what you could see and what you could hear, but your brain is also an ongoing map of your experience. You have knowledge based on what you've done and what you've seen and what you've heard previously, and you use that knowledge to inform you about what's around the room. So if I point over there and I say, what's that object? You would say, that's a pen, because you have prior knowledge of what that object is. You learned that at some point, and you can access that information immediately, which is remarkable. Your thoughts, on the other hand, tend to be a little bit more spontaneous, but we often aren't controlling our thoughts as well as perhaps we should. But that's the second job, which is to generate all these perceptions, thoughts, and behaviors in a way that reflects our prior experience. So that's the second thing, that you've got the ability to generate perceptions, thoughts, and behaviors, and then you've got prior experience, and you can draw on that prior experience. And the third job is that that's a highly adaptable map. It's an adaptive map. So your brain has this incredible ability to learn new things today and to implement those things such that when you go to sleep at night and wake up tomorrow, your brain is going to be a different organ. Not entirely different. You still know you're you, Anthony. Itself an interesting thing. You wake up every morning, you don't ask yourself who you are, you immediately know. That's itself an interesting biological problem. But let's just say that the brain takes care of that, because it does generally take care of that really well in healthy individuals. But you wake up the next day and your brain has changed because you've learned something new. And you can often do new things based on something you learned the day before, perhaps learning a new language or learning a new physical skill. So, the brain is this highly adaptable map of the world that is responsible for all our perceptions, thoughts, and behaviors. There, I gave you the one sentence that you asked for at the beginning. I just had to arrive at it backwards.
That was
sorry
great.
About that.
No, it was fantastic. What research has come out in the past decade that you're really excited about because it indicates our ability to rewire our brain and to change our brain, and that this organ can adapt and improve?
Yeah, great question. I love this topic so much. This is what we put under the category of neuroplasticity, or the ability for things to change. So if something's plastic, you can change it. I think about putty. You can reorganize it in any shape you want, like a kid playing with Play-Doh. One day, make a little, a fire engine, and then, so another kid can pick it up and grab it and turn it into a little bulldog or something like that. So, your brain isn't that malleable in terms of changing its overall shape. Thank goodness. It needs to fit in your skull. There are good reasons for that, to protect it. But the most exciting research to me is the research that takes advantage of what we know from childhood, which is that during childhood, especially the first 6 to 9, maybe even 12 years, the brain has one major job, which is to take in tons of sensory information through the ears, eyes, nose, skin, etc., and learn new things, organize that information in ways that the behaviors, perceptions, and thoughts are arranged in some sort of meaningful way. What do I mean by that? So a kid goes to school, kindergarten, first grade, and is learning words at an incredibly rapid rate. And yet the brain actually learns more words than the kid ever experiences during the day. So this is incredible, right? It's not like the teacher sits there and say, okay, the, and, frog, house. They do that. And they learn all those words, which itself is miraculous. I couldn't learn that many new words in a new language today. But not only that, but the brain somehow learns how to put those together into sentences. The brain picks up words that are conjugations of those two words. The kid can learn past tense and future tense. Things that are taught individually are chunked together and established into this incredibly elaborate ability, which we call language. And if you step back for a second and just think about what we can engage in now as an adult, the ability to exchange information rapidly here, just by listening through our ears. I can close my eyes and I can still hear what you're saying and understand what you're saying, although there's meaning in your facial expressions too, and those help. That's an incredible ability that I never forgot. And so it's during childhood that immense amounts of information are put together because the brain is so plastic. It's designed to be plastic at that stage. Now, you asked what is the most interesting thing to happen in the last decade or so. And I would say the most interesting research, my opinion, is the discovery or discoveries that show that the adult brain also maintains this capacity for incredibly rapid learning. The important thing to recognize is that there are certain principles that come from that research which tell us, and this is mainly the work of a guy named Eric Knudsen, who also happens to be at Stanford before I arrived there and before my laboratory arrived there. Eric has been doing these studies for decades in barn owls of all species. It turns out this is also true for humans, which is that in young animals, they can learn tremendous amounts of information in huge steps from day to day, just like a child learning tons of new words or a ton of language each day in school. For us, taking a language learning class, like if I want to learn French, I'm going to have to do it in slightly smaller chunks, and it's much, much harder, and I'll probably never learn how to speak French without an accent. It's very difficult. Incidentally, children can learn multiple languages without an accent. Incredible. So the ability to learn as an adult, it's clear from the work that Eric has done and the work that others have done in different species, including human, that in order to learn a lot as an adult, you want to chunk things down into smaller bits of information. You don't want to try and accomplish 100 new words a day. You set out smaller chunks, But if you do that more frequently, you get just as far as you would if you were trying to learn it all at once early in childhood. So what does that mean for you as an adult if you want to learn something new? It means don't try and take on too much. Take on small amounts of information and then perform that learning more often. Now, here's a twist in all this, which says, that the kind of greedy person in me, or the ambitious person in me says, well, you know what? I want to learn as quickly as I was a kid. I'm just not going to be satisfied until I can learn as quickly as I did when I was 10 years old. That's what I want. I'm 40 years old now, but I want to keep learning the rest of my life just as I did when I was a kid. So Eric did this incredibly important study, which has a beautiful result, which is that if you create very strong incentives, the adult brain will learn just as quickly as the baby brain. And we kind of know this intrinsically. So if you say to me, Andrew, tomorrow I want to hear you speak, conversational French, just 3 sentences back and forth. I'm going to say a sentence, you're going to say a sentence, I'm going to say a sentence, 3 sentences each back and forth. And let's put a wager on it, $1,000. This is a decent sized amount of money for me, or most people. You wouldn't want to walk away from $1,000.
Right.
Chances are I'll learn, but I might fail, okay? Now, if you take a gun and you put it to my head and you say, you know what, tomorrow I'm going to pull the trigger, I'm going to blow your head off unless you can engage in conversational French back and forth, 3 sentences each, you can bet I'm going to speak conversational French tomorrow, at least to that capacity. Now, this is also true from the animal studies that people have done, and Eric's is the one in particular, which is that these animals have this adaptive plasticity early in life that's very rapid. In adults, it's much reduced. You learn a lot less, you have to chunk things down, everything's inconvenient about it. I want to learn a lot now, I'm going to Paris in a couple weeks, I'm not going to Paris in 3 years. So what do you have to do? You have to create really important incentives. And so, of course, putting a gun to your head is not a good incentive. That I do not recommend that to your viewers. But you have to create incentives that are meaningful. And we know this over and over again. When someone is desperate to get something done, it happens. And that's also true for learning new information. And just as a final tidbit to all this, what's wonderful, and I won't delve into the mechanism too much, is that the same mechanism underlies this ability. It turns out that it's the amount of a substance, what's called a neuromodulator that you make in your brain called acetylcholine, that's released during the learning episode that dictates whether or not you remember that information or not. So studies have been done where you trigger the amount of acetylcholine to be very large during learning, and it's an incredible result. The learning is rapid, it's permanent, and it occupies huge regions of this area of the brain that we consider the map, the cerebral cortex. Whereas if there isn't much acetylcholine, then you generally don't learn as much. The map doesn't change as much. Your sort of map of your experience doesn't change. And so what we know is that acetylcholine is gating how much learning you can get. Now in children, it seems you need less acetylcholine around in order to get a massive amount of learning. But as an adult, when just to stay with this example, when you put the gun to my head and you say, you're going to learn this, all of a sudden my attention goes up. Acetylcholine gets released, and I really focus on whether or not, when I'm reading my book on French, whether or not I'm really paying attention. And the key word is attention. If you go into something, and I used to do this when I was in college, and you say, oh boy, calculus, I really don't like this stuff. This is tough. This is tough. Or you read, or you get to the end of a passage in an English literature class, and you think, oh, what did I just read? You're not paying attention. But if you tell yourself, this is the most interesting topic, so this is just a simple hack that anyone can try. You want to remember something? Just for the moment, delude yourself, even just lie to yourself. Say, this is the most interesting topic. Say it out loud. This is the most interesting topic that I could ever be interested in. And then read the passage as if you're going to recite it to somebody in a moment. You will retain that information much better. Why? Well, just telling yourself it's interesting engages your attentional systems, and then you focus on it, and when you're taking in that sensory information, which is just your eyes scanning the letters on the page, or you hearing the words in your head, then you're paying attention and you retain that information. So this is one of the great mysteries, and I think the great successes of modern neuroscience, which is, why is it that kids who don't seem to be paying attention at all can learn all this stuff almost passively? Probably because there's just a lot of acetylcholine around, and the brain at that age is just a passive learning machine. They're learning like crazy. This is also true in puppies. For those of you that ever had a puppy, they're picking things up, they're dropping, they're learning interactions with the world all the time. As an adult, not only our behaviors get more constrained, but we stop paying attention to things. And so paying attention increases acetylcholine. Increasing acetylcholine will change your neural maps, and changing your neural maps will allow you to learn information as rapidly as you did when you were younger. These are facts that are extracted from the literature. These are things that one can really just engage in a behavioral way and in a cognitive way at any moment.